LeetCode problem 1497. Check if the array pairs are divisible by k. So the problem states, given an array of integers array of length n and an integer k, we want to divide the array into exactly n by 2 pairs such that the sum of each pair is divisible by k. Return true if you can find a way to do that, or false otherwise. Okay, so let me explain what the problem tells. So we have an array. Let's take the first example for better understanding. We have 1, 2, 3, 4, 5, 10, 6, 7, 8, 9. So we can make the pairs in this array as 1 and 9. So if we add them up, we get 10, which is perfectly divisible by k, right? Which is perfectly divisible by 5. Then we can take 8 and 2, which will give us again 10, which is perfectly divisible by k. Then we have 7 and 3, which give us 10 again and perfectly divisible by k. We have 6 and 4, again it's perfectly divisible by k. Then we have 5 and 10, which give us 15, which is perfectly divisible by k, right? So we need to find all such pairs, and if you can pair if you can find all the pairs, then you can return true. Else, if you cannot pair at least one number, then you have to return false, right? So the given array will always be even, right? So only then you can make n by 2 pairs, right? So that's what the problem says. So let's start with the intuition of how to solve this problem. So basically this is a modulo arithmetic problem, so we have to use modulo here. Let me explain the concept of modulo. So let's say we have k is 5, right? So whatever the number, if we divide by k, we will get the remainder from 0 to k minus 1. So that means 0 to 5 minus 1, which is 4, right? So what I mean is, let's take 1, 2, 3, 4, 5, 6, 7, 8. So let's divide everything by 5, right? Let's divide everything by 5 and get its remainder. So dividing 1 by 5 will give us 1. Dividing 2 by 5 will give us the remainder 2 itself, right? The same goes for 3, 4. So when we divide 5 by 5, the remainder is 0, right? So 0. Then when we divide 6 by 5, we get the remainder 1 again. Then for 7, 2. Then for 8, 3, right? So as you can see, the number will always be in between 0, 1, 2, 3 and 4, right? So with this, we can find an intuition of solving this problem, right? So for simplicity, I'm taking 1, 2, 3, 4 and 5, 6. Okay, so let's assume my k is 7, right? So I have 1, 2, 3, 4, 5, 6, 7, right? So let's start with the first number. I have 1 here. So if I need a pair which will be divisible by 7, what should I add with this? What should I add with 1? I should add 6, right? Only if I add 6, I will get the value as 7, which is actually divisible by 7, right? So do I have 6 in my array? Yes, I do have 6, right? I do have 6. So this will always be divisible, and we have got the valid pairs. Okay, so now let's move to the next number. We have 2. So adding what number with 2 will I get a number which will be perfectly divisible by k? 5, right? So we have 2 and 5. The same goes for 3. Adding 3 with 4 will give me 7, which is divisible by 7, right? So this is one of the observation. So no matter what number we have in our array, if we divide everything with our k, we will always get the numbers which with in between 0 and k minus 1, right? So in this also you can observe that the numbers is in between 0 and 6. So it was easy for us to find the pairs, right? So let's take the first example itself. We have 1, 2, 3, 4, 5, 10, 6, 7, 8, 9, and the k is 7. The k is 5, right? So we have taken the first example. Let's try solving this, right? So we have, if we divide the remainder of 1 divided by 5 is 1, right? We have 2, here 3, here 4, here it becomes 0, here also it becomes 0. For this it becomes 1, 2, 3 and 4, right? So let's sort this. We have 0, 0, 1, 2, 3, 4. Okay, sorry. So there are 2 1s, 2 2s, 2 3s and 2 4s, right? Okay. So even here you can observe all the numbers are in between 0 to 4, right? Which is k minus 1. So what can we do? What can we do here? Do we have any observation that we can make? Right? Return the index. Yeah, we can see that there are 2 zeros. That means we have exactly 2 numbers which is perfectly divisible by k, right? So if we have 2 numbers which is perfectly divisible by k, if we add those 2 numbers and if we divide by k again, we will get a perfectly divisible number, right? So we can say that these two are perfectly paired, right? So now let's move to the next number, which is 1. So with what number can we add with 1 so that we will get a number which is divisible by k, right? How will we find this? We just need to take k. What is k? K is 5, right? If we subtract with 1, which is negative 1, what will we get? We got 4, right? We need 4. So do we have 4 in the array? Yes, we do. We do have 4, right? So that means these two can be a perfect pair, right? Because 1 plus 4 is 5, which is divisible by 5. So these two are perfect pairs. Okay, now let's move to the next number. This is same again, right? We have 1. We need a number to be added with it so that we get a perfectly divisible by k, right? So we do have 4 again. So these two and these two are can become a perfect pair, right? Yeah. Now what can we do? Now let's move to the next number, which is 2 again. So 2. So we need a number that can be added with 2 to get a perfectly divisible number with by k, right? So k is what? K is 5. If we subtract 2 here, I get 3, right? I need to check whether 3 is there in the array or not. I do have 3, right? So yeah, I can make a pair again. So I can get 5, which is divisible by 5. The next number is also 2, and this is also 5, right? Adding this to also 5, which is divisible by 5. So we got all the numbers and we can make a pair of it, right? So we can return true here. So this is how we solve this problem. Just don't worry about the numbers. We just take the modulo and we get all the numbers which are in between 0 to k minus 1, and then we iterate one by one. We find what number is needed to add with it. Then if the number is present, we can pair it up. If we cannot find that number, or if we cannot find that number, that means there is no such pair and we cannot make a pair with it. We can return false. So that's what the intuition is. Now I'll tell you how to code this up. So before this, we need not track everything in an array. We can use frequency to track that. How do we do that? So I will explain that as well. So for that, let's take a frequency array. So the frequency array the size of the frequency array should be exactly k, right? Why? 0 1 2 3 4. So the k is 5 here, right? So we have exactly 4 numbers, right? We have exactly, so everything will be 0 initially. Why do we have only 4? Because as I said before, if we take modulo of any number of k, it will always be in between k minus 1, right? 0 to k minus 1. So that is why we have taken only to 0 to 4 because the k is 5. So let's start iterating from this. So we have 0 twice, right? So the frequency of 0 is 2, and we have 1 twice, right? The frequency is 2 again, and we have 2 twice, the frequency is 2. We have 3 twice, frequency is also 2, and 4 twice. That means we have 2 zeros with remainder. We have 2 numbers with remainder zeros. So that's what it means. We have 2 numbers which has the remainder 4. So that's what it means. So first of all, we need to check especially for 0, right? So 0 should always be an even number, right? If it is not even, we can immediately return that we cannot make a pair of it, right? Because if we add two perfect numbers, only then by adding them up it can be divisible by k, right? So if we have 3 such numbers which is perfectly divisible by k, then adding that extra number which is the third element with any other number, we cannot make a number which is divisible by k. So that's why we need to check whether the first index is always divisible by 2. It should be even number. Yeah, in this case it is even. We can make a pair of it. So we just move to the next element. It's 1 again. Now we do 5 minus 1 is 4, right? This is the index of the array. 5 minus 1 is 4. So does the index 1 and index 4, does the frequency of 1 and 4 matches? So we have 2 ones, we have 2 twos, right? That means we have two numbers here which can be matched with 1 and 4. So yeah, this can make a pair, right? Two pairs are made here. So this is a valid. Now we move again. We come here, we check whether we can make a pair. It's 2. 5 minus 2 is 3, right? So 3 is here. We have even here the frequency is same. That means yeah, we can make a perfect pair. Yeah, so this is how we solve the problem. And one thing they have given in the constant is we can have negative values as well, right? We can have negative values as well. So how do we get modulo of negative values? So for example, if I have negative 1 modulo 5, that means if we divide this in Java, we get it as negative 1 itself, which is wrong because we need values in between 0 to k minus 1, right? But negative 1 is out of scope, so we need to move this ahead, right? So let's take the number line. I'll explain it for better understanding. So we have negative 1, negative 2. Let's take this number line. So now what happens? I have negative 1, right? So if I divide negative 1 by 5, I get negative 1 itself, right? So but I need a positive number. So what I will do, I will add negative 1 with 5. So now what happens? It moves ahead. 1, 2, 3, 4, 5. So the value is 4, right? So 4 is my value. So 4 is my modulo, right? This is how you handle for negative numbers so that the values will be in between 0 and 5, right? So yeah, this is the intuition of solving this problem. And now I'll be sharing the code. This is the code of the problem. We have a number array to track the frequency. So the size of the number array is k, as I said before. Then we are getting the modulo and incrementing the frequency, right? We are increasing the frequency of this, right? This frequency array. So this is our frequency array. So we are incrementing the indexes, the frequencies, right? We are incrementing the frequencies. So what I have done is I have taken the modulo, right? And what is this k? This k is what I explained here. If the value is negative, we need it in positive, right? So that is what I have added here. Then you can ask that why do we do this modulo modulo of k again? So because we do this because if we do this for negative values, it can be handled perfectly, right? But what if we have positive values? So let's say we have 2 modulo 5 is 2. but we are adding k right here. Why? To handle for negative values. So if we add again k, I get 7, right? So that is the wrong values. So for negative values it will be handled perfectly, but for positive values we will always increase a k, which will again give us the wrong value. So again we do it percentile 5, which will return back the value again. So by doing this we handle the positive values, right? So this will be handled for negative values. So positive values to be handled again, we do percentile kill again. So this is how we increase the frequency, and then we check initial condition. If the first index is always even, if it is not even, we return false. If it is even, just continue. Then we check for exactly half numbers, right? Half of the array. Half of the array, we check whether we have the same frequency, right? Whether the frequency is same as I explained here, right? As I explained here, if we have the same frequency, then we continue, else we return false. If all these conditions satisfies, finally we return true. It means that we have found perfect pairs. So I hope you guys understood this problem, and if you did, please give this video a thumbs up, and see you in this next video. That's it guys, bye bye.